Hey folks, how's everybody doing out there? At the end of the last installment of our History of Software in three-letter acronyms, the mighty International Business Machines Corporation, IBM, was in crisis. This was the dawn of the 1960s. The Soviet cosmonaut Yuri Gagarin had just become the first human being in space. The Soviet Union was winning the space race. The United States was gambling on free market capitalism to deliver the technological superiority that would help them win the Cold War, and had engaged IBM to create a supercomputer for their nuclear weapons research laboratory at Los Alamos. But the result, known as Project Stretch, was a disaster. Underpowered, overpriced, and the company was still losing millions of dollars on every unit they sold. Thomas J. Watson Sr., the single-minded entrepreneur who had led IBM for over 40 years, was dead, and his son, Thomas J. Watson Jr., had bet the future of the company on a radical new line of intercompatible computers and peripherals called System 360. It looked like an incredibly risky proposition. But Tom Jr. knew the era of punch cards and tabulating machines was over. The future belonged to digital computers, and if IBM was going to remain relevant in the world of information technology, it was now or never. In 1963, IBM engineers made a breakthrough: emulation microcode. Not only would the new System 360 be able to run software written for earlier IBM computers, it would run it faster, and it would run multiple programs concurrently. For IBM's salesmen, and they were overwhelmingly men, clean-shaven white men in dark suits, shirts and ties, 2 pens and 1 pencil clipped neatly into their shirt pocket, for them, emulation was a dream come true. They could tell potential customers, yes, the new computer will run your existing software and give you room to expand. On April 7th, 1964, IBM introduced the world to System 360. 6 computers, along with dozens of peripherals, keyboards, disk and tape drives, printers. The press release was an inch thick. The documentation and manuals for the new systems and software filled over 50 feet of bookshelf space. Interested customers could place their orders right away, with the smaller Model 30 and 40 due for delivery in around 18 months and the more powerful models in the first quarter of 1966. Plenty of time for those customers to remodel their buildings, install new power, air conditioning, train their staff, and prepare to take delivery of their new machines. When System 360 was announced in April 1964, there were around 20,000 computers in the world, total. Within a month of the announcement, IBM had taken orders for over 100,000 of the new systems. Now it just had to deliver them. 18 months to go from hardware prototypes and wooden mock-ups to running systems. Tom Jr. brought in his younger brother, Arthur, to run the project. Arthur Watson, a charming, talented linguist who spoke French, Spanish, Italian, and German, had been in his 3rd year at Yale when World War II broke out. He dropped out of college to join the army, rising to the rank of major by the time the war ended in 1945. Arthur joined IBM after the war, running the company's world trade operations and consolidating IBM's position in Western Europe. Oblivious of the problems that lay ahead, Tom Jr. saw System 360 as an opportunity to bring his brother back into the heart of IBM and prepare him to eventually take over running the company. But as the project became mired in delays and problems, manufacturing, logistics, endless software defects, and spiraling costs, Arthur Watson was unceremoniously removed from the project. His IBM career never recovered, and he retired in 1970. He briefly served as the United States ambassador to France, but his final years were marred by alcohol abuse. In 1974, he fell down a flight of stairs in his home and later died of his injuries. He was 55 years old. For the engineers brought in after Arthur's departure to turn the project around, System 360 was a nightmare. A grey blur of 24-hour days, 7 days a week, never being home, as one of them later described it. But failure was not an option. With billions of dollars invested in factories, transistor fabrication plants, engineering facilities, and hiring tens of thousands of engineers, the future of the company was riding on System 360. A final compounding factor was the widely held perception, both at IBM and elsewhere in the industry, that software wasn't actually worth anything. Customers were paying for the hardware, and the operating system and applications would be thrown in for free. The cost of developing the software for the new system had originally been estimated at around $30 million. As it rose to $50, $100, eventually $500 million, the costs had to be accounted for, wiping out budgets and profit margins in other areas of the company. They turned it around. You know they did. If they hadn't, IBM would have gone down in history as a tabulating machine company that went bankrupt about the time of the moon landings, and this video would be about IRC or the IETF or something. But within a few years, most of the problems were resolved, and thousands of System 360 computers were delivered to customers, with IBM's revolutionary new disk operating system, DOS, included for free. One of the lead engineers on the System 360 project was Fred Brooks. Over a decade later, Brooks would document his experiences working on the project in The Mythical Man-Month, one of the most influential books ever written on computer engineering. A significant cause of delays was the operating system software known as OS 360, and based on decades of experience in manufacturing, Brooks' solution to the delay was to hire more engineers. To his surprise, it didn't work. The more engineers they added to the project, the further behind schedule they fell. As Brooks later realized, the biggest overhead in a software project of this scale is communication. As you add more people to a team, the amount of work they can deliver scales linearly, but the amount of time it takes to coordinate that work with the rest of the team scales exponentially. An observation that would become known as Brooks' Law: adding manpower to a late software project makes it later. Fred Brooks' work on System 360 included another hugely influential decision. Based on his experience of stretch and its variable field length, Brooks decided the System 360 architecture would use fixed-size bytes. 1 byte was 8 bits. Earlier systems had used a 6-bit byte, but as Brooks would say years later, of all my technical accomplishments, making the 8-bit byte decision is far and away the most important. The reason was that it opened up the lowercase alphabet. I saw language processing as being another new market that we were not in and could not get into very well as long as we were doing 6-bit character sets. The success of System 360 established 8-bit bytes as a standard that's still ubiquitous to this day, but another equally significant decision would split the world of computing into IBM mainframes and everything else for decades to come. IBM systems had historically used a text encoding system called BCD, short for binary coded decimal, a 6-bit encoding designed in 1928 to encode alphanumeric data onto Hollerith punch cards. By the time the company started working on System 360, work was well underway on a new text encoding standard, ASCII, the American Standard Code for Information Interchange. IBM was actively involved in creating the ASCII standard, but for System 360, adopting a new text encoding system that was incompatible with any of their previous systems, that would have been a step too far. And so the 360 shipped with a proprietary 8-bit encoding system called EBCDIC, the Extended Binary Coded Decimal Interchange Code. The rest of the world would embrace ASCII and later Unicode, but to this day, IBM mainframe systems use EBCDIC as their inherent text encoding, with the current IBM Z-series mainframes having dedicated hardware instructions for translating between EBCDIC and ASCII encodings. The author Jim Collins once described the System 360 as one of the 3 greatest products of all time, alongside the Model T Ford and the first Boeing passenger jet, the 707, pioneering machines that launched entire industries. Even today, in 2025, if you book an airline ticket or make a bank transfer just about anywhere in the world, there's a good chance an IBM mainframe computer is involved somewhere along the way. But by the start of the 1980s, the IT landscape was shifting. Companies like Apple, Commodore, and Altair were selling microcomputers, a fraction of the power of a mainframe for a fraction of the price. IBM had once dreamed of a computer in every country, then in every city, then in every company, and now a ragtag group of upstarts working out of their garages had come out of nowhere and sold the world on a new future, a computer on every desk. You folks probably know what happened next. Some of you were even there. IBM realized that desktop microcomputers represented an all-too-real threat to their share of the business computing market. But they also knew that the IBM name carried weight, and the best way to retain their share of an evolving market would be a desktop computer with an IBM badge on the front. But just as the lessons of Stretch paved the way for System 360, the lessons of the 360 would define IBM's next move. They'd bet the company on a new product once before, sinking billions of dollars into custom chip designs, fabrication plants, developing entire lines of peripherals, and although it had worked, everybody involved knew it was a once-in-a-lifetime gamble. The IBM PC was the diametric opposite. The watchword was, don't invent anything. In fact, right from the outset, the project was to be as un-IBM-like as possible. CEO Frank Carey appointed a product engineer called William Lowe, Bill, and gave him a brief to find 40 people, move them all to Florida, and keep them as far away from IBM's layers of entrenched bureaucracy as possible. Buy existing components and software wherever you can, bolt them together into a package aimed at the consumer market, and keep the whole thing secret. If IBM's competitors found out about the project, that'd be one thing, but if IBM's own mainframe sales teams found out the company was developing a personal computer, things could get very complicated indeed. Folks who have been following this series know exactly how things unfolded from here. The saying goes that the rest is history, but for me, and I suspect for a lot of you, this is the point where it isn't history anymore because we kind of watched it happen. IBM went to market. They bought off-the-shelf CPUs, interface boards, keyboards, printers, and an operating system, which they call PC-DOS, from a tiny software company in Seattle called Microsoft. Yes, with a hyphen. It's almost poetic that 2 decades after System 360 introduced the world to the concept of compatibility, it was the phrase IBM compatible that heralded the beginning of the end. Since the IBM PC was assembled from generic components, it turned out just about anybody could build a computer that would run the same applications and use the same peripherals as a real IBM PC. Hardware had become a commodity in a fast-paced market where IBM's sheer size was a disadvantage. The success of the original IBM PC and its successors, the PC XT and the PC AT, was short-lived. And by the mid-1980s, IBM realized they were losing control of their market. Software, not hardware, would be the deciding factor in computer sales for the foreseeable future. In response, IBM went into partnership with Microsoft to deliver a successor to DOS, the hugely ambitious OS/2. But despite delivering several successful versions of OS/2, Microsoft was focusing their development efforts on their own Windows operating system. With the runaway success of Windows 3.0 and an increasingly apparent culture clash between the way the two companies preferred to operate, the partnership was dissolved. IBM would maintain control of OS/2 version 2, and the nucleus of OS/2 version 3 would become the core of Microsoft's new Windows NT operating system. In 1994, IBM had one final spirited attempt at regaining control of the desktop computer market with OS/2 Warp. With the most advanced internet and multimedia capabilities of any operating system yet, the ability to run programs written for Microsoft Windows, and a publicity campaign that went in hard on the idea of warp speed, right down to hiring Captain Picard himself to MC their launch event, it might just have worked. But Patrick Stewart couldn't make it on the night. Instead, it fell to Kate Mulgrew, Star Trek Voyager's Captain Janeway, to fly the Starfleet flag, which would have worked just fine if anybody knew who she was, but Voyager wouldn't hit the airwaves for another 6 months. Things went from bad to worse when Paramount's lawyers got involved, explaining that although the word warp was a completely normal English word that anybody could use, the phrase warp speed and its associated connotations were Star Trek trademarks that IBM did not have permission to use. IBM's marketing agency came up with a new campaign, a series of celebrity endorsers talking about warping their PCs and how totally warped their working day was. Yeah, OS/2 lost the desktop war before Windows 95 won it. IBM wouldn't even pre-install it on their own computers, let alone pursue licensing deals with other manufacturers. IBM's PC division was terrified that machines without Microsoft Windows wouldn't sell, and hence they'd miss their sales targets. A month before Windows 95's August release date, IBM chief executive Lou Gerstner told the company's financial analysts that IBM had lost its opportunity to go after the desktop. The New York Times spun this into IBM chief concedes OS/2 has lost desktop war. It would be massively disingenuous to say that was the end of IBM, but it's also fair to say that from the mid-1960s to the mid-1990s, the vast majority of people working in corporate IT would come into direct contact with IBM's products on a daily basis. By the time Windows 95 rolled around, that chapter was over. Well, apart from one outlier. In the early 90s, IBM put together a team to design a line of state-of-the-art portable computers, which they called ThinkPad. 30 years later, ThinkPad is still one of the world's most popular and successful laptop brands. It's just not owned by IBM anymore. They sold the ThinkPad line to Lenovo in 2005, along with the rest of their PC manufacturing business. The IBM of the new millennium has been at the forefront of research into artificial intelligence and quantum computing. In 1997, IBM made headlines when their one-of-a-kind supercomputer, Deep Blue, defeated world chess champion Garry Kasparov under tournament conditions. Kasparov said afterwards that, for the first time in the history of mankind, I saw something similar to an artificial intellect. In 2011, IBM Watson, a supercomputer designed to process natural language, competed on the US television game show Jeopardy and defeated the reigning human champions Brad Rutter and Ken Jennings. Watson firmly established the idea of natural language interfaces in the public consciousness and was an early precursor to modern language models like ChatGPT and Copilot. Later this year, IBM plans to unveil the world's largest and first parallel quantum computer. Really though, the future of IBM isn't about the future, it's about the past. If any of you folks out there has worked on any kind of digital transformation project for a really big company, you've probably had the meeting where you're mapping out all of the existing systems, web servers, databases, VPNs, applications, and somebody asks, what's that box there? And gets the answer, oh, that's the mainframe. We're not allowed to touch that. Banking, insurance, government, healthcare, aviation, basically any industry that had computers prior to 1980 probably still has IBM mainframes. Not the original ones, no. They'll be running the latest shiny IBM Z series, hugely parallel systems packed with dozens of processors, terabytes of RAM, capable of running Linux, Java, any number of contemporary software applications, and all that old mainframe code written for the System 360 way back in the 1970s. And that's the problem. There are still engineers out there with the knowledge and experience required to maintain mainframe applications written in Fortran and COBOL, but there's no delicate way to put this, they're getting old. The computer whiz kids of the 80s, they're in their 60s now, and there is nobody to replace them, which means those industries have to make a choice. Do they try to teach a new generation to write COBOL? Do they migrate those apps to C# or Java, millions of lines of undocumented code, some of it more than 50 years old, that's responsible for billions of transactions per day? It's no surprise there is an IBM team working on using Watson, yep, the one that won Jeopardy, to automatically translate COBOL code into Java. It'll be an interesting project to watch. Unlike a lot of the so-called AI systems out there, Watson X isn't about producing flashy demos to conjure up another round of investment. It's about solving a real problem that real customers actually have, and you bet those customers are ready to pay real money for a solution. IBM has never been cool. Well, apart from the ThinkPad. The suits and ties, the layers of management, the million-dollar computers that couldn't even speak ASCII. In many ways, IBM was proudly antithetical to the cyberpunk hacker ethos that built the web, Linux, email, social media. Heck, compared to IBM, even Microsoft is still a scrappy tech startup. But IBM's influence is inescapable. If you're sat at a desktop computer right now, the keyboard in front of you is probably based on the layout designed by IBM for the original PC. The RAM chips inside your computer use technology invented by IBM. The relational database, the foundation of so many modern applications and websites, invented by IBM. But there's a point where technology becomes so ubiquitous, we stop thinking of it as technology anymore. You go to the store to buy groceries. The barcode on the back of the cereal box, invented at IBM, 1973. You swipe your credit card to pay for it. Magnetic stripe on the back of the card, IBM, 1969. Or maybe you'd rather pay cash. Cash machines, IBM, 1972. The electronic checkout that takes your payment and prints your receipt, IBM. The 6-figure booking reference you get when you buy a plane ticket, IBM. Folks, we could go on, and I suspect we'll be seeing IBM again before this series is out. But I want to wrap up with a story that's been doing the rounds for decades, but I still rather like it. When Thomas J. Watson joined IBM's precursor, CTR, in 1914, one of the things he established throughout the company was the slogan, think. Just think. That one word was printed on stationery. It was the title of IBM's employee magazine. It's where the ThinkPad would eventually take its name from, and it was stuck up on signs throughout the company's offices, including in the toilets. And legend has it that one day an IBM employee went to wash their hands and noticed that alongside the official company sign above the hand basin reading Think, somebody had printed out a much smaller sign in the same style and stuck it just above the wash taps. It said, Thope. Folks, I hope you found that interesting. There are links in the description to all the various books and sources that I've used in putting together this video, so check those out if you want to know more. In the next installment of our history of software in 3-letter acronyms, initialisms, and abbreviations, J is for JVM, the Java Virtual Machine, which was only invented in 1994, so I'm hoping there won't be quite as much history to study as there was for this one. Until then, folks, thanks for tuning in. You take it easy out there, look after each other, and I'll catch you next time. Bye-bye.